You're on mute, Pam.
Great. I am now unmuted. Thanks, Kurt. Welcome, everybody. Thank you for joining us on this beautiful summer afternoon. I hope your summers are going healthily, safely, and smoothly during these difficult times. This afternoon, we're going to be going through training number 4 in the ADAS series. Today, we'll be focusing on intelligent high beam assist, front collision warning, and hill descent control. As always, the meetings are being recorded, and the recordings and the PowerPoint presentations are on the ATL website. If you have any questions or issues with the recordings or the PowerPoints, just please get in touch with me. We will not be having a meeting next week, July 3rd, because of the holiday, so we will reconvene for training number 5 on the following Friday, July 10th. So without further ado, just wanted to wish you all a happy July 4th weekend, and I'll turn it over to Kurt, who again, as always, has our thanks for his generous leadership and competence and just incredible leadership on this. It's been incredible. Kurt, thank you.
Cool, thanks. Let me go ahead and switch over to get everything going here. So hopefully
While he's doing this, I wanted to give an update real quick to some of the Bay Area colleges who are in the Electude Regional Joint Venture. It looks like it's going to happen. I have yeses from 8 of the remaining 9 colleges. So I'm putting together the final proposal for next week, and it's looking good. So cross your fingers.
All right, so hopefully everybody can see a screen there. It says Seminar 4, Intelligent High Beam Assist, Front Collision. Thank you, Tom, because you're the face that I can see, so I appreciate that. So today is going to be a continuation of what we've been doing, very similar in the mindset of where we've been with bringing to awareness for everybody a lot of these technologies. Some are very new that we've talked about through the series, and some are fairly old. A couple of the things we're talking about today, they've been around for a little while. Again, we're probably around an hour and a half, depending on how the conversations go. Again, it's to introduce. There's a fair number of people that have never heard of these things, others that have a lot of background with them. So it's all across the board. Don't be afraid if you've got these vehicles or experience in these systems. Make sure that's what you're conveying in classes. Teach to your strength. These are all meant to be generic and using generic information, generic test equipment, things like that. So that just gives you more avenues to work with. As always, let's try to keep the questions in the chat. We've got the breakpoints in there that we'll stop and read through the chat and try to answer all the questions that we can. Again, it's not a deep dive. We're not trying to certify anybody. The PowerPoint is in widescreen, so if you haven't been in here before, you might have to adjust your window a little bit. And again, Bosch and Steve Zach for all their help with materials. We're going to talk about intelligent high beam assist, and this is not going to include adaptive and active headlights. That's another conversation, even though a lot of the time you'll see these systems run together. Front collision warning and hill descent control will be our main focuses today. Again, there's no one way to do any of this stuff. It's however best to get it to our students. Like Pam mentioned, to get to these, go to that same ATL website. You're going to go into the faculty area, click on the curriculum area, and you'll see a new tab. It's a little different than the screen picture you see right now. It'll say the webinars, and within that has both of the recording and the PowerPoint for each of these. And then if you go farther down into it with the ADAS stuff, it's got some of the older, very shell type presentations, and then all the Bosch materials. If anybody's been watching the news the last couple of days, if you teach EV and hybrid, it's a good chance to start looking at expanding your horizons. CARB just passed all the regulations for heavy truck to be EV, some of which starts in 2024, so it's rather aggressive, and then 20 years before everything rolls in. So, hey, an electric motor is an electric motor, a battery is a battery, and an inverter converter is an inverter converter. So the things you're teaching in your automotive hybrid classes or EV classes is very applicable for heavy duty truck guys too. So you might be able to share some of that information with your program. So just a heads up with that. So let's talk about intelligent high beam assistant. Now, we've all been behind that car or in front of that car that drives around with their high beams on all the time, or the guy that passes you on the freeway with the blue light glowing away on their dashboard. And, you kind of go, well, duh, turn your high beams off. Well, a lot of people don't realize they're on. And nowadays, with more and more vehicles having automatic headlights, you still see a fair number of them driving around at night with nothing but the park lights on and no headlights at all, because they don't have it in automatic mode. They think it's automatic headlights, just like automatic wipers. They don't work. You'll see a few different names out there depending on the manufacturer and the year. You might see intelligent high beam control. You might see intelligent high beam assistant. You might just see high beam assistant. Again, no standards, no structures with these names. It's pretty much up to the manufacturer what they want to call this. This system is usually independent. So you could have this with any headlight configuration, has nothing to do with active or adaptive headlights. Whether it's halogen all the way through LEDs, any of these systems could have this. Again, utilize your strength, utilize your students' experiences with it. And like I've said in the past, I like to start with a video to kind of give an introduction to the system, to give us our students and everybody a point of reference to begin from.
To activate the intelligent high beams, rotate the headlight switch to the on headlight icon or the auto position, and push the lever away from you into the high beam position. Then, press the intelligent high beam button to the left of the steering wheel, and a green LED will illuminate in the instrument panel. This feature comes in handy on dark roads. Here's how it works. If you have the high beams on for added nighttime illumination, when the system senses another vehicle approaching, or if you're approaching another vehicle from behind, it automatically switches to the low beams. After the system senses the vehicle has passed, or the distance between the two vehicles increases, it automatically reverts back to the high beams. To disable this feature, simply pull the lever towards you and switch to low beams.
So as you can see, it's helping us lazy drivers be even lazier, to where we get to drive it around with brighter lights more often, and then hope and pray that the system does what it's supposed to do by dimming them down for us. That's a big benefit. We all know that it's harder and harder to see with a lot of the headlights on cars. Even some of the new cars, the headlights aren't that great. So anytime we can have more light in front of us, the better, especially as we get older. So these systems are beneficial in that aspect. They are going to use cameras in many cases. That's what's picking up that oncoming headlight or seeing the lights in front of it. But they'll typically also use a photovoltaic cell or a photovoltaic sensor. And that sensor is basically measuring an ambient light or a light that's coming into it. In a sense, it's like a variable resistor. Based on the amount of light, that's going to change the voltage. It's going to change how the system operates. So it's going to recognize that vehicle oncoming light or those tail lights as well as the ambient light, and essentially switch the system from high beam to low beam when it needs to, but the primary trying to be on high beam as much as possible. If we can light the road better, things are safer for the drivers. Hopefully accidents decrease, all that kind of fun stuff. And again, this is going to be an active system. That's the whole purpose of it. Is it for it to be active so that it will switch between the high and the low? Not necessarily a passive. There's probably no benefit in having the thing tell you, hey, change your headlights. So the operation is pretty straightforward. We're going to use that camera and solar sensor. It's going to see that light detection, whether it's from the headlights directly or through the photovoltaics. It's going to recognize those ambient light conditions. And that's primarily what the photovoltaic sensor is there for. If I'm in the daytime and I've got the lights on automatic and things like that, then I don't necessarily need the high beams going off and on. But you do get into some of these situations where even in Southern California, they've got a stretch of highway that it goes through a tunnel and there are skylights in that tunnel. And some of these systems can actually react and actually essentially turn the, like an active headlight, turn the headlights on and off. But with the active high beams, actually bump them on and off, because all of a sudden it sees dark, sees no traffic, brightens the lights, and then all of a sudden it sees this daylight from the skylight, and then it knocks them back down again. And you'll get some complaints from customers on some of the systems like that, on the early ones when they only had one. Later systems actually went to two photovitalics, one looking up to pick up the ambient light directly from the sun, but one looking out that helped recognize that skylight scenario in tunnels. We don't see it a lot out here, but they are out there, and Europe has quite a few of them. And that was where a lot of the systems started coming from. So it's going to recognize those conditions. It's going to get that information, and a module is going to make a decision to turn the high beams on and turn them off as need be. And the idea is, hey, let's give maximum light whenever possible. So let's think of some things here, though. That tunnel we talked about, to where it could shuttle on and off on us. But what about in a corner? So if I'm in a corner and I've got the high beams on, until I see another oncoming light or I see headlights, there's a good chance I'm going to dazzle or blind that driver coming on, or I'm going to suddenly hit light on the car in front of me. Those are a normal scenario. There's really nothing they can do to prevent that, because it's directly in that line of sight for the vehicle that's going to have that control. So if it's going around a turn or something, it's not going to pick that up. What about in a vehicle where they've tinted the windows? And you go, well, they don't tint the windshield. Yeah, they do in some places. Arizona, Texas, it's not uncommon for them to tint the windshield as well. So if I've tinted the windshield, now I've basically put sunglasses over top of that photovitalic sensor. So it's not going to pick up the ambient light situations correctly, and it may affect the camera as well. So you could have a customer complain of, hey, oncoming cars are flashing me all the time because my high beam assist doesn't automatically knock down. So beginning to look at other things that would create a problem for it, but would be a normal scenario for like a corner or a tunnel. Components themselves, you're going to have a camera or cameras. A lot of new vehicles, we're seeing as many as 3 cameras. In some cases, those cameras have 2 functions, a short and a long distance function. You're going to have whatever modules are applicable for the camera, for the headlight controls, etc. You're going to have a control switch. This is typically a system that the customer is going to have to activate. They're going to have to turn it on. They're going to have to make that selection. You're going to have your photovitalic sensors, and you're going to have some sort of visual indicators, typically in the instrument cluster, just like you would normally have with your high beams, telling you that you're in that high beam assist mode. Okay. Now, if we think about this, as we start to look, what would be some of my diagnostic things? You can already see, based on we're using cameras, we're using photovitalics, what kind of things that we might need to look towards when we begin our diagnosis. Also, the discussion for the students would be what other systems might be involved in this. If I had a car that had an active headlight, how much of this is overlapping with that other system? The same camera that's working for my intelligent high beam could be the exact same camera that's working for my lane departure, or for some of the other features, pedestrian recognition and things like that. So if I had a problem in one system but not in others, now I start to use that as a diagnostic tool and saying, hey, that camera can't be a problem for this because it's working with all those others in many cases. So our diagnosis, hey, like we've been saying, we start with the visuals. We've always started with duplicate the complaint, and that still exists. We're still going to look for, fault codes. We're still going to look at our information, SIBs, and all that kind of stuff. But with all of the ADAS related things, that visual inspection takes on a greater importance. So as we're going through those, we've really got to look for, is the windshield cracked in front of that camera? Have they added tint? The little Subaru on the picture there, he's got a roof rack. Well, that roof rack is overhanging in the windshield. That overhang on the windshield and the extra light bar that they've got on there, is that casting a shadow to where it doesn't see the ambient light source the way it should? And maybe the system's working in a thinking it's darker than it really is and having some reactions during the day. You know, an oncoming car is flashing them because you think they think you're flashing them because the system's shuttling. So different things like that can come into play. When we're doing our electrical testing, again, this is going to be the biggest thing with all these ADAS systems, is we really are going to be heavily in the electrical testing with these, because that's really all we can do. We can check for fault codes, we check the functions, and then it's the foundation basics. Do we have power? Do we have ground? Do we have signal on that bus, whatever that kind of bus might be, going from the camera or sensor to the module? After that, now software comes into play, and that's something we haven't talked about a lot. But if I had a line of code in the software that wasn't working correctly, no different than on your cell phone, that system may have some functions that aren't correct. Maybe it needs to be updated. Maybe that module just needs a complete reflash, or maybe I now have a hardware problem. So there are some things that can be done, but we've got to eliminate the basics first. And also external conditions. What's the weather like? If that front windshield's covered with mud and crud, or ice and slush and snow, or you're going through a heavy snowstorm or hailstorm or whatever, back to what we've been saying from day one, if you can't see, the car can't see. So all of those weather conditions come into play on how well this system's going to function. Clarity of road signs, not a big deal for the intelligent high beam function, but it's one of those foundation pieces as we look through. But again, driving conditions are going to be a big piece of it. Having a lot of extra time with the scan tools. Let the students find what they can find in these systems. You may be surprised, it's not uncommon to be able to go into whatever module is seeing, say, the photo sensor, and actually see a value in, say, a PID page, and look at that live data stream, and then actually check that photo cell. And that has become difficult now. You either need to pull the car outside and let sunlight hit it, or find an old flashlight with an incandescent bulb, because your LED flashlights typically won't create a reaction on these photo sensors. It'll look at it and say, yeah, no big deal. But you hit it with an incandescent light, even a dim one, and you'll see that voltage reaction. So having the awareness of how you're testing it can impact what your outcomes are going to be. Did you test it correctly and get the correct outcome from that? Service and calibration, well, it's using cameras. So that means we're going to have to calibrate it. We're going to be using targets. Whether the sensor is hard mounted or adjustable isn't going to matter. We're going to use targets. In some cases, they may be a self-calibrating system. It may be a combination of both, where you do a mechanical and then you do a driving to re-support that. Lens cleaning stuff. Now, in some cases, you do have some cameras on the vehicles, oftentimes like for their active radar sensors and things like that. Some vehicles actually have a spray nozzle, and they will wash the lens off occasionally. The cameras on this particular system are going to be inside, up by the rearview mirror behind the windscreen. But hey, maybe just hitting the window washers and cleaning that portion off, because when you think about it, on some cars, that area right there, that triangle of doom behind the rearview mirror, may not get swept. A lot of the newer cars that do have cameras there, the wiper angles have changed a little bit, so they sweep that area, but maybe you have one that doesn't. Okay, so those are some things to keep in mind. Really nothing to show you for calibration on this one. You know, we'll talk about it on a couple more here. So let's take a look and see what we see in the chat here. So let me buzz through here real quick. Robert said, Cadillac used a variation of this system in 1955 through 1980s called Guide-O-Matic. Yeah, it's not new. It really isn't. They've had little things like this for a long time, and they've kind of ebbed and flowed through the years, and as have a lot of electronics. There was stuff in the 50s and 60s that are now kind of standard because the electronics finally got good enough to keep. John Taylor, are there any standardized distances or illumination measurements for dimming with oncoming or forward vehicles? I think it's every manufacturer has their own thing. Whether there is a fixed standard somewhere, I don't know. but they all seem to, be in that 50 to 75 yard range, the few things that I've read on them. So you're going to be in their mirror pretty good before the system dims down. And I don't know if they do that just to make an absolute confirmation. And this is, again, when you're coming up on a car. I think that distance gets a little bit greater when it's an oncoming car and it picks up the headlights from that. So it tends to be a little bit different. Ruben asked, where's the sensor located? The forward-looking camera, again, is pretty much going to be behind the rear view mirror inside the vehicle, looking right out through the top of the windshield. And those photo cells oftentimes are in that same area. Sometimes they're physically on the mirror itself, and you might see two of them. They'll usually not a blue in color. The blue in color are usually the ones for the automatic wipers. That's the little prism, but it's just kind of a little clear lensed device. Sometimes you'll see it tinted and be a little fisheye lens. Some of them are just looking outward, some are just upward, and some you may see one pointing out and one pointing up. It's not usually, from what I've seen, not usually the same one that they're using in the climate control system. But there's really nothing stopping them from using the sensor in the climate control system, because oftentimes when they've incorporated that in a climate control system, it's for solar detection to modify the climate function. So if it's seeing daylight and that's the only one they've got, then they could use that one as well. Paul had asked, what year did these systems come out? Well, like the one guy said, in the 50s. We've started seeing them more regularly, I would say mid 2000s and later. I know GM had it on a lot of vehicles. It was kind of a big deal with them. We saw that in BMW range, somewhere around in that same area, that early mid 2000s. And I think nowadays they're becoming more and more common. Let's see here. Mark had mentioned the headlight module used to be the controller. A newer control module is now called the driver assistance systems control module, according to Audi. And yeah, we're kind of seeing this ebb and flow. A long time ago, everything had its own module, and then they went the other way and they put everything in one big black box. And then they realized, well, that may not be a great idea, because if that one big black box goes out, then nothing works. And then they started pushing things out again, and now they're pulling things back together again. So it tends to go back and forth. The key word that you're gonna probably want to use is distributive functions. And distributive functions is really something that goes along with all of these computer controlled systems in vehicles. Because we've got all these modules networked together, I could have the inputs coming into module A and all of the processing be in module B, and have the outputs be in module C. So it's however the different manufacturers want to control it. Oftentimes you'll see the information come from a camera and go into a module who may be in charge of multiple systems, but ultimately, like on a newer car, they're going to send that over another bus back to the headlights themselves that probably have their own module, especially if they're an active or an adaptive headlight. So vehicle dependent, I would even say model year dependent, as manufacturers go from more or less at any given time. I see Mark's box glue up. You got something, Mark?
Yeah, so I'm reading on a 2019 model, and the interesting thing about their high beam is it's little segments in the light, right? They're LED segments in the headlight, and they say they can make it a certain cone as far as how it projects, forward to the oncoming car. And then I just reading about laser headlights. I'm like, well, how does that work?
We're going to talk about those in one of the future sessions. I think it's actually the week after we get back from the 4th of July, where we start talking about active and adapted headlights. And I've got a little bit in there in the laser, as well as some of these beam focused lights, to where they physically will change the light output to where they can dim it on the oncoming traffic sign and keep it on a high beam on the other side. They can split it. They can do a lot of things with it on these newer headlight systems. But laser adds a whole nother dimension for control and lighting and things like that. And we'll touch on those. I think it's next week when we touch on that stuff. But yeah, and even on current cars now with just an LED, they can really do a lot with the LEDs because it's essentially instant on. With the halogens, you had a little bit of a lag time. When you got into xenons, you have some lag time. With the LEDs, the lag's essentially gone, and they can do a lot of control with those more and more aggressively every day. And we can have more light output with a smaller surface space. So now aerodynamics improve. So there's a huge thing happening with lighting now, from a physical functionality to design characteristics to aesthetics. All of those things are coming in play.
As I'm looking at this picture, this last thing I'll say about this, it's showing blobs of light going out at different widths and ranges.
Yeah.
And I think that's just how it's projecting multiple light beams in different ranges.
Yes.
Yeah.
They can actually split. They can literally like make the beam into a Y, to where, like, say you've got a car coming on your left, the right headlight stays out at a distance. The left headlight can actually go wide, or it can go down, or it can go to the right to control so that they don't dazzle the incoming cars. So yeah, it's crazy. And I've got a lot about that stuff in the presentation when we talk about those. Ed Woodworth had, if the sensors won't pick up LEDs, how will they pick up LED taillights? And that's one of the things you're starting to hear, is some of these systems are struggling with LED lights. And I just heard that within the last week or two for the first time, that there were some vehicles and some sensors, and they didn't say what it was, whether, I'm assuming it's a camera. The photocells really aren't meant to pick up the tail lights or the oncoming traffic lights. They're there for the ambient light. So it's got to be something with the cameras. Now, what my theory is, and I've got absolutely nothing to document it on, is you have the frequency rate of the camera, basically the Hertz cycle that the camera is creating its picture from, and the frequency rate of the LED. We've all seen like old videos on when there was a TV or a monitor in the background, and you'd see that scrolling line as it wrote the picture. And as the TVs have gone to a higher refresh rate, you don't see that line as much, and the cameras don't pick it up as much. And my thinking is you may have that scenario with some of these cameras, that the LED frequency is such that the cameras don't pick it up effectively. So in their mind, hey, there's no light there, and the high beams would stay on. So hopefully that's older technology, or maybe it's a software update, as it becomes more and more a problem. Because believe it or not, there's still a lot of cars out there that don't have LED taillights. They might have LED headlights and things like that, but there's cheap spots on cars sometimes, and taillights still seem to be one of those areas where it's hit and miss. It might have LEDs, it might have bulbs, it might have both. It's kind of all over the place. Michael sent a screenshot. I'm not going to open it up right now because I don't know what it is, and God knows what might happen, but I'll assume it's something that supports what we've been talking about. If you're on here, Michael, you can chime in real quick and let us know. And Robin had mentioned lines of resolution. Yes.
It is just an ad for Guidematic from 1954.
Oh, okay.
It was the Autronic Eye. So you can,
Yeah.
it won't, it's nothing.
No problem. Thank you.
So.
Yeah, but yeah, it's all over the place, and we're seeing these things more and more. They haven't called it to be a safety thing yet. Like they're going to have some of the ADAS in the next couple of years. But I think as we see these systems more and more, we're probably going to see things become more and more standard equipment. We saw that with airbags. Airbags were an option, and then they became the norm, and eventually they became regulated. So Ed Snyder had one in here. Could a radar-equipped vehicle be tied in with a distance? Could a radar-equipped vehicle be tied in with a distance to vehicle factor? For the headlights, typically when you read these systems, they talk about just you focusing on the camera, on picking it up. But let's be realistic. As we've talked in the past with the whole sensor fusion thing, the same modules are getting information from the radar sensor. They're getting it from the cameras. They're getting this information from all these other areas. it's just a line of software, you know, the coder who decided, no, we're only going to look at the camera, or no, we're only going to look at the radar. It wouldn't take anything for them to say, hey, you could use both. And I haven't heard of anybody openly saying they're doing that. When I talked with BMW, there was a few systems to where they said it did this, but I was 99.9% sure it was also doing that, just because of the way the system was. But they didn't come out and say, yes, we're also doing this with it. You're starting to see that more and more as the semi-autonomous gets deeper and the fully autonomous get deeper. This whole sensor fusion thing, it's going to be the norm. I've got all this stuff. I've got all that information all the time. Why not use that in addition to whatever my primary sensor input is? So I think that's, you know, something that's probably there on some and may not be there on others. Going forward, it's probably going to be on everything. They're just going to have a greater spatial awareness around the vehicle. Kaylin asked, how is sensitivity adjusted by the driver? You know, on the headlight stuff, I haven't heard there being a sensitivity adjustment, and I may be wrong on that, but I have not heard of it having any adjustability. Obviously, if you change the vehicle heights, that's going to impact things, you know, raising it, lowering it, all that kind of stuff. But I haven't heard where, you know, like an active cruise control where you could change that distance. I haven't heard that with the lights, but that may or may not be the case.
Hey, Kirk, could I jump in for a minute?
Yes, please.
Okay. So on the Ford system that had been around since the 80s, the adjustment was basically for the auto high beams, was right on the mirror. Customers loved it. It was easy for them to adjust the different lighting conditions. But when they put it in the instrument cluster and they had to scroll through all the buttons to do it, they struggled with it. That's why.
And that was for the automatic headlights, not dimming mirrors, though, right?
No, automatic
Okay.
high beams.
Yeah. Interesting. Yeah, I hadn't seen it.
Like
So that what they just gave them like 3 levels and depended on how close the car was before it finally dimmed.
Okay.
I mean, that's why I'm asking you. I haven't dealt with the system.
Oh, so basically you could adjust the sensitivity of the automatic high beams for, you know, different lighting conditions, whether you're on an old country road or around a bunch of lights, and it would let the car get closer or maybe engage it when it was further away. But when they put it in the instrument cluster and you had to hit all the buttons on the steering wheel to find the adjustment, that's when customers struggled with it. So.
Yeah, and based on your description, because it, you know, needing that fine tuning to recognize if I'm in the city or country road, that's probably a system that wasn't using a photo sensor.
It had one on the back of the mirror, and it basically just picked up the light coming towards you and adjusted the high beam.
Yeah, because that would definitely be one that, you know, you wouldn't have to do that manual if it had the photo sensors going at it for you. And that might be in a system, if that was just using the photo sensor, at that age, it probably wasn't using a camera. It was just using a photo sensor to pick up the oncoming lights. Right. With the newer ones, it's using the cameras, the photo sensors, giving us that fine tuning with the ambient lighting.
Okay, cool.
So, and again, you brought it up there. It's an 80s car, you know, so these systems, they're not new. They're not new. They're just getting more whiz bang buttons. Let's see here. John Taylor asks, can we put the switch back on the floor for our left foot where it belongs? No, because that's, you know, that's against handicapped people having something they have to push with their foot. Just kidding. And the foot control button to change the radio stations. Hey, now you guys are getting really old there, and, you know, that's just way out of line. All right, let's keep moving. Front collision warning. And this is another one of those systems, Jesse mentioned real quick there, just like the third pedal. There was 3 pedals. So front collision warning system, this is another one that it's probably going to be one of those ADAS systems that's going to be required in a couple of years. I haven't heard specifically, and somebody that's really deep in SAE might know, but they're going to be requiring, I think it's 2 or 3 ADAS systems by model year 2021 or 22 or 23 or something like that. It's in the next couple of years. And I see you, Mark, hold on. And a lot of people have said, okay, yeah, we think it's probably going to be these front collision warnings because so many of the cars already have active cruise controls or emergency braking and things like that is what a lot of people are expecting. I haven't seen it in writing yet, but that doesn't mean it's not out there somewhere. You got something real quick, Mark?
Yeah, I'm sorry somebody mentioned before about regulations and things like that. And I was just reading about this high beam on this car doesn't come on until vehicle speed of 43.4 miles per hour is reached as a statutory requirement, some statutory requirement.
Huh, that's interesting.
Yeah.
Because I've seen it on cars at like 30 miles an hour. So that may be just an Audi thing and maybe tied in with European. Because sometimes we see some of these functions that have a European regulation that don't necessarily have a US regulation. And they'll just embed some of that in there since it doesn't have to be different for the states. I saw that in European cars in the 80s. You know, rear fog lights were a big thing, having 2 rear fog lights. And then until the states changed the rules, then they went to 1. They were great. Get traffic off your butt in a hurry. Turn your rear fog lights on. It was like 2 brake lights jumping out in their face. So front collision warning, a lot of different names: forward collision warning system, collision avoidance systems, collision detection warnings. Again, at this point, no standardization whatsoever. The big focus of this is a vehicle or large object. This isn't necessarily a pedestrian protection system. Even though it might be using the exact same sensors and the exact same result if it's an active system that can bring the car to a stop, the algorithms in it are looking for big objects, not people. Okay, and that's really the difference in it. And you see this stability control systems, the brake systems. There are a million different little sub functions in brakes nowadays, from brake drying to, you know, pulsings and things like that. Or is your foot on the brake? Is your foot not on the brake? Is the parking brake on? Is the parking brake not on? That bring on these little sub functions depending on a situation. So collision warning and pedestrian protection, the difference is really algorithms and what it's looking for. So pedestrian protection recognition, it's essentially a kissing cousin to this, and it's going to use the same stuff. It's just a different software line that if the car says it's got pedestrian protection, it's probably got the front collision. If it's got front collision, it may or may not have the pedestrian protection depending on who and when it was made. Again, let's take a look and see what this system does.
Forward collision warning and autonomous braking systems monitor traffic in front of a vehicle and warn the driver of a potential collision. Sensors determine the distance and relative speed between vehicles. If the system thinks a collision may occur, it warns the driver, usually with an audible alert, which may be accompanied by a visual alert on the instrument panel or on the windshield. Some warnings may produce a physical sensation, like tugging on the safety belt or pulsing the brakes. Most systems also pre-charge the brakes to maximize their effect if the driver responds to the warning. If the driver doesn't brake or steer to avoid a collision, some systems may close the windows, tighten the safety belts, or adjust the seats and head restraints to reduce injuries. Some systems automatically brake the vehicle to mitigate the severity of a crash or prevent it altogether.
I find it interesting that on some of the systems that they mentioned, that it will go through all this work of rolling up the windows and tightening the seat belts and things like that, but it won't write the line of code that will basically go over and tell it to brake. So I think that's kind of funny. As you can see, depending on the variation of the system, it could have a lot of variables. So some of the early ones, hey, all you're getting is that warning, driver, do something. By the time you see it on a car today, you're really talking a system that's fully active. It's going to bring the car to a stop. So you could have any variation in between there. It's really going to be year, manufacturer, model dependent. And most of that just comes down to what code did they write? Did they just want this system to recognize, or did they want the system to act, or how much did they want it to act? So that's the big thing with these. You'll typically see these systems come out with a limited functionality early. And then as they've proven case on the hardware and the software, those different things start to evolve out into having greater functions, greater capacities, but they didn't change anything other than the software. So big thing with this, hey, recognize potential frontal collision situations. If we do that, everybody's going to be safer. We're going to have less accidents. And again, we can have everything from a passive system that just gives warnings to an active system that can increase your safety protection all the way up through stepping on the brakes. So the operation, we're going to use sensors and cameras. You're seeing that mix. Early systems, they were almost all dependent on just a radar sensor. Then it went to a camera and a radar, and that's more and more, we talk about that sensor fusion, you're seeing this more and more where the systems are utilizing more than one thing. It gives them that confirmation. And we're going to use it to detect a frontal object. Now these systems, especially if we're talking radar, it's going to recognize that closing distance. It's going to recognize that moving vehicle at the rate it's moving and things like that, because that's going to change how that system reacts. If the car is doing 60 in front of you and you come up on them at 80, that's a different reaction than if that vehicle in front of you is stopped and you come up on that vehicle. So these systems are going to use as much information as they can to make the decision as to what they're going to do. Idea is, at the very least, provide the driver enough information so that the driver can do something. And that's typically what you'll see with the new ones. You're going to get those reactions. You're going to get those warnings. And if you don't do something and it's a system that's capable of bringing the car to a stop, the car is going to come to a stop. It's giving you the chance to do your job. And if you don't, it's going to do its job to keep itself alive. Yeah, you'll get to stay alive at the same time, but it's worried about keeping itself alive. These systems are getting smart. So they may pre-tension the seatbelt. Why? In case of an accident. And that was the same reason why I talked about rolling up the windows. They roll up the windows so that it reduces the amount of incoming materials, glass, parts in an accident. So they're prepping that system to be able to say, hey, something may be happening here. Let's see here. It kind of covers those pieces. The warning system components, camera, radar sensor, or sensors, depending on the system. Obviously, you're going to have your brake system module in play, airbag system in play, because remember that airbag, it might be the one that's in control of the seat belts. It might be in control of the seats, the steering wheel. A lot of new cars, they have seat belts that will pre-tension. So it can tighten the belt with an electric motor so that it doesn't have to blow a charge to tighten it. They can actually tension it and release it as they need to. Many, many years ago, Volvo had some reactive things in seats to where you were in an accident, the seat back would move in such a way to reduce whiplash. You now have some of that with the electric seats to where they can change that headrest positioning and stuff in an accident so that it can reduce whiplash. We're going to have control switches, but not control switches to turn this thing off in many cases. This is one of those systems you're probably not going to be able to turn off, kind of like a fundamental ABS kind of thing. We're going to have some visual indicators because it's going to want you to do something first. You're going to have audio indicators because, again, it's going to want you to do something first. For students, you could bring this conversation up to what other systems might utilize these same things? What other systems could be in play on a new one? So where you're looking for them to bring up, hey, the brakes, the airbags, the engine management, maybe the transmission to help slow it down. What if this is a hybrid or an EV? Hey, now we're going to kick into some regenerative braking. What if this system's another level or two down the road to where maybe we have a steering action to where we can avoid that accident with a steering correction. So you can see how these systems can evolve, and really it's not new hardware, it's new software that comes into play with a lot of these things. Diagnosis, damage, where it's our glass for our sensors, our bumpers, covers. This Subaru could have some issue. He's got his off-road lights there. He's got his winch hanging out of there. Maybe he's in front of something a little bit. He's obviously lifted the vehicle, so now our view cone is different. All of these changes, whether it's going up or down, or we've covered it with something, all of these things, we can't take it as a given. Every single time we're going to start diagnosing an ADAS system, we've got to look at all these things over and over again. Paint damage, paint correction, alignment. I kind of left that one hanging as an assumption, but hey, our alignment comes into play with all of these things, along with our electrical testing. And again, it's testing. Lots of scan tool, lots of electrical testing. So it's a great class to support bringing things together. I mean, if a person wanted to bring these classes in, yeah, you could bring them in topic at a time, but it really lends itself to kind of a capstone class for your program. As they've gone through other classes, now when they come in here, they're using that integration of all those different systems for ADAS. And how do I test those functions? Well, I got to go into those other systems to double check their functions as well. So targets, hey, we've got cameras, we've got radar, which means we've got targets to deal with. We may have self-calibration to deal with, may have dynamic calibration to deal with. But again, it's this same cycle. It's a good repetition of habit to build in. I'm checking my alignment. I'm making sure my thrust is where it needs to be. I'm going through and doing my targets as need be, whether it's driving or static. And one thing we haven't talked a lot about is the simple act of the steering angle sensor. That's something that is now a given, or should be a given when you're doing an alignment. You should be doing that steering angle sensor. Okay. Are we remembering to do that? Because if that steering angle sensor is wrong, it's going to have a very big ripple effect across a lot of different systems. Systems that we might not even expect it to react, it can affect. All right, so let's take a look and see what we've got in the chat here. Let's see here. So John Taylor, with these new systems, is most of this data being recorded for the black box so that the insurance investigators can use the data after an accident? Yes and no. There's not as many black boxes in cars as people think. There's very few cars out there that have, a full-on flight recorder type of thing. I know, was it the Nissan GTR had one there for a while that really captured a lot of data. Now, I see you, Mark, don't worry. There's a lot of stuff that does get picked up in things like an airbag sensor. It can pick up certain things. Some engine management will pick up certain things, but it's not as cut and dry as people think of. Oh, they can go pull the black box out like a crashed airplane and get all this information. A lot of the time it isn't there at all. Or what is there may not be from the accident that just happened. It might be, the day before or something like that. In some states, it's actually part of the vehicle registration. If you get your vehicle registered in that state, you automatically give the police agencies access to that data that could be used against you. In other states, it's considered personal data and they'd have to take you to court to get it. So that whole black box thing's way up there. And again, it's all over the place. Manufacturers for years have had the ability to go into like airbags and modules and pull out information to see if it met a threshold and things like that. But I've never heard it being something that they actually were able to strongly use in court for or against. It was kind of it had a fault, it didn't have a fault, it met the threshold, it didn't meet the threshold. More of an information point more than you're guilty type of thing. Mark, you had something?
Oh, shoot, I'm sorry. And I was chatting about something else. No, I'm sorry. I lost that thought. Go ahead.
It's all good. Mark had another one in here. I had a situation where traffic stopped suddenly in front of me. I got a warning light and I heard ABS pump energize and it even applied the brakes. Amazingly accurate distance detection. And that's exactly what it's supposed to do. The scary thing is when you hear what it takes to go double check the system operation. Because you hear of techs driving fast up onto cars and hoping and praying that it throws the brakes on and stuff. Yeah, that's the scary part, is how are you going to test it for sure to confirm that it works versus the assumption, yeah, I think it'll work. It doesn't have any fault codes.
It was pretty scary, Kurt. It was, it was partially that I reacted a little bit late to the traffic, and then I was like, well, wow, what a cool system that actually can fill in for me. They're very good, these systems, amazing. I'm still having trouble though with my automatic rain sensors coming on all the time. Sunny, shady, I'll swipe the windshield clean. That thing keeps coming on a little bit more now, but I don't know. I'm just going to monitor it.
Is the windshield getting old? Because that was one of the things that we saw. Because remember, a lot of those use a little prism on the glass. So it's got like a little light sensor, and then the light's going to go out. And if you can see my picture, it's going to bounce around in there, and then it's going to come back to a receiver. And if there's anything on the glass, what happens is some of that light deflects off and away. So it receives less light, and that's what tells the system, oh, there's something on the glass. As the glass ages or pits, you have a higher potential for that deflection, and the system can swipe when there's not anything to swipe.
I have to look a little bit closer. There might be a chip there.
Yeah.
And I think I remember the thing I was going to say is I was looking for the collision, mitigation stuff, and then I found out what Audi was calling it. They're calling it emergency assist, and that's more if the driver also passes out. It's going to not see steering wheel function, not see brake function or gas function. It'll start bringing the car to a stop if the driver passes out.
Wow. That's a whole nother level of stuff. That's what, 2019, 2020?
2019 A8.
Yeah. And that's tied in with that driver drowsy system.
And it's more, I think it's just also more logic, Kurt, right? Mm-hmm. It's just actually a program that is now taking more steps, right? And so this is close to the autonomous kind of stuff. Yeah. To me, autonomous is just more sophisticated communication between control modules.
Yeah, because when you think about it, we've already got the system. We've got the electric steering, we've got the electric throttle, we've got the electronic control transmission, we've got stability control that can activate the pumps without your foot on the pedal. So all it is at that point is taking in sensor information and making a decision of what it wants to do. And that's why, we're not as far away from autonomous as people think. It's just that volume of data is the challenge, and having an AI at the high enough level to do it. A lot of us were down at Mobilize last year, and the guy from NVIDIA was there, and he was talking about their stuff. And the big thing that they're all waiting for is not the technology to catch up. It's actually for the regulatory to catch up and say, here's the minimum standard. When the government comes out and says, this is the minimum standard for these systems to achieve, and once they know that minimum standard, now they know what they need to be at, and they all expect that they're probably already beyond whatever the minimum standard will be. They're not worried about the liability side of it. They figure that's going to sort its way through the courts anyways. Their big concern is, what's that minimum requirement so that they can say, I can meet it or exceed it, and then have these systems out there. You've already got millions and millions and millions of miles on these systems live driving. Forget about how many times that they take that algorithm, they take that recording from the car and run it through a supercomputer all night long and drive it another million miles overnight kind of thing. And that was one of the things with these things. It's every time they make one change, they go and drive that loop again. Every time they change something, they drive that loop again to see how it improves, see how it reacts. So it's much more on the computation side. The hardware we've had a lot of this hardware for quite some time. Ed mentioned possibly not programmed to have vehicle come to a stop to keep you from being rear-ended by the car behind. Yeah, and I think early on it was just they were playing safe. Nowadays they try to bring the car to a stop if it needs to come to a stop. If it doesn't need to come to a stop, it probably is going to try to maintain as much distance as it can, not to get in the wreck, but like you mentioned, not come to a complete stop so the guy behind you doesn't hit you. And that's always a concern right now, is you could have that brand new Audi, which can stop in a postage stamp, but the guy behind you is an old Volkswagen Bug who needs, a mile and a half to come to a stop. these systems can create accidents because of their effectiveness and their efficiencies, based on what the vehicles around them are.
Kurt, I think that also for rear end collision, doesn't it? It senses that through the radars you have in the bumper, and then it's going to tense the seatbelt and adjust your headset or your
Exactly. Depending on the car,
ADAS.
yeah, you're going to have some stuff there. And I've even read something on some of the systems that if they suspect a rear collision, that it actually releases the brakes. So by releasing the brakes, now the car gets punted and the car rolls, which reduces the energy transfer, which reduces potential injury and stuff. So lots of things that can come into play. It's a line of code. You know, the hardware's there. It's a line of code to tell it what to do. Adrian mentioned Volkswagen Ayrton has hood engines that pop up to cushion the pedestrian hitting the hood as it's deployed. And the funny thing is I've joked about it for a long time with BMW. We always called it scoop and loop. Europe has European protection, pedestrian protection built in their cars. That's the reason a lot of the cars are very flat in the front. The idea was when you hit somebody, you threw them on the hood and the whole hood would collapse and the air filter housing would collapse and all these things would collapse to absorb the guy that you just hit. Whereas in the States, we built these pointy cars to shove them underneath and just kill them off the rest of the way. But it's just different. I heard somebody was playing around with talking about putting airbags on the hood for pedestrians. And I'm thinking, okay, let's just not hit them in the first place and we don't have to put airbags there. So we're working on those things too, I guess. Steve K, any way to tell the difference between an active or a passive system besides using a bale of hay and see if the car stops? You'd have to get into the manufacturer materials. That's going to be the key, is you're going to have to find the operating description for that system for that year, make, and model. Because the following year, it may be different. You know, it may go from a passive system on a 2010 to an active system or a semi-active system on a 2011. But even in 2010, maybe the Camaro got passive and the Cadillac got active. You know, manufacturers do, you know, a lot of weird things depending on what vehicle it's on. A lower equipped car, a lower model line car, a more cost-effective car is going to have less features than the higher end car. And it could be just lines of code that are different. Ed Woodworth, pretension without explosives, so it must be temporary and motorized. Yeah, we do see the older airbag systems, you had the pretensioners, and you still have pretensioners in a lot of the new systems, but we're also seeing motorized so that they can pull the slack. And you'll even see that in some of the performance cars, to where as you get into a performance mode and more aggressive driving, the seat belts will actually tension to keep you in the seat. The seat bolsters on your sides will come in and kind of hold you in more like a racing seat as the G-forces increase in curves, so that you're in the seat better and you're more stable. So yeah, there's a lot of things going on with that stuff. Mark had mentioned some numbers on the Audi stuff. Ruben, we used a beach ball with rear collision system, maybe an idea. And I think the rear collision, and that's a great idea, I think the rear collision is a little easier, only in that it's usually I'm assuming he's talking about the cross traffic one. So if you're backing out of a parking space, it recognizes a car and the car would come to a stop. Those are a lot easier to control because you're not moving very fast. But if I'm driving down the freeway, go ahead, Ruben.
Hey, Kurt, that's in reference to the question about how do you tell the difference between the bale of,
yeah,
system or an active. So we were looking at that because they have the warning system and the active system. Mm-hmm. And so what the instructor down there at Subaru said, he goes, hey, let's try a beach ball. We can find out that way. You know, so we just threw a beach ball at it, and one system stopped, the other system didn't stop and just warned it. So that's how we found out.
And that was on the frontal or on the rear?
That was on the rear. On the frontal, I have another comment down below about an actual mock-up that they used at Sinclair College, which is just a big foam pad, and it has it has a simulation of the rear of a vehicle, and we used that and actually crashed into it a couple of times, and found out which system was passive and which system was active.
Yeah, and that brings up a good point, because in a quick YouTube search of front collision stuff, you'll see a lot of these static targets. And it's interesting because some of the vehicles, they'll react really good on a static target. So they'll have like a car cutout, and like Ruben said, a big chunk of foam cut out like a car, looks like a car. So the cameras can see it, the radar sees it. It's got the right kind of surface so the radar will actually detect it and bounce it. And some of the cars will react really good to the static and not react so good to a vehicle moving. So if they towed that target and pursued it, some of the systems didn't work as good with that, and other systems worked better with the vehicle, with the target moving and the vehicle moving, than it did with the static. So it's all over the place. Light conditions seem to come into play with some of them because of the reflective qualities, I guess. Weather conditions could come into play because anything that affects that radar return could affect this. The reason I was asking rear and front is the rear system, you know, by nature, you're backing out of a parking space. So if something's, you know, bicycle, kid, whatever is coming up, that system, you're not moving much. It's much easier for it to react. The front one gets a little scary because cars got to be moving. So that one's a little scary, but I like the beach ball. Mark mentioned driver pass out. We talked about that. John Taylor, rental vehicles, you know, and this is, I've heard this with a few different people, and they've said, hey, go rent a car with all this stuff. If you've never driven it, go rent a car with all this stuff and feel it. Because a lot of the rental fleets have these at various levels, especially if you're getting a newer Toyota. You know, Toyota Sense in 2019 has a lot of these systems on everything. So you could go out and drive a lot of these systems and get an idea what they're like. Now, I'd be really careful, you know, saying, I want to see if it'll work, and here's a brick wall, let's see. You know, that's usually preceded by, here, hold my beer, right? So let's not try to do it that way and find out if that system works. But we have to take it on faith a little bit. But I've heard of techs that will get on the freeway, they'll aggressively roll up on a car in front of them to see if they get the warnings and stuff. Not so much to see if it goes into the emergency stop, but if they get the warnings. If they get the warnings, the system's getting the reaction. Theoretically, the algorithm should work and apply the brakes in the right situation. I think most of the time they're just trying to confirm that it recognizes the target and gives that first set of warnings, because the next steps would be the braking. But these systems could also have some issues. Let's think about that. What if I was coming up a hill and I'm just about to crest the hill and the traffic stopped and I couldn't see it? My sensor is looking up still because of the positioning of the car. My camera is looking up. So there's situations on, you know, a high incline, I might have a collision because I haven't crested yet. Same thing coming down. If I'm coming down enough, my sensor may not see the car because it's looking at the bottom of the gully before it comes up. So there's some scenarios here that, just because of the nature of the location of these things and the cone coming out of them, it may miss things.
When they
go ahead,
come
John.
out with a sensor that'll do that, I need to put one on my 72 Mach 1 because the hood's so long you can't see anything in front when you're cresting a hill.
You know, I think what could be interesting is as an active sensor that has maybe a sweep to it or something, you know, who knows? Who knows? You overlap enough stuff, you know, with LiDAR and radar and cameras, you know, theoretically you'll cover all the bases. Ruben, this is about the dummy that we got a chance to talk about. He says he's got pics and part numbers. That's awesome. Joseph, I know for a fact GM and Ford had access to information that was proprietary to manufacturers when the vehicle was in a wreck. I'd worked with GM on a court case and was able to shadow GM and engineer with the scan info. Yeah, and I've known that from the European cars. In Europe, the European manufacturers, when there was an accident like on the Autobahn, sometimes the very first people to get there was actually BMW, Porsche, Audi, Mercedes-Benz. They got there before the police, fire, and ambulance, and they were there to collect data, take pictures. They were there to confirm that the vehicle crumpled and crashed the way it should, and that was part of their engineering testing. And, you know, they could get to a lot of that data, but there's a lot of question on, can the data be used against you and not used against you? And even in the States, like I mentioned, some states, it's part of the registration of the vehicle. If you get a registered vehicle in that state, you're giving the right to the police agency to solicit that data from the vehicle. And there's been court cases about that saying, it's kind of like you ran a red light and your wife called the cops on you when you're in the car. Can they really do that? Can it be held against you and stuff? So there's a lot of questions on whose data is it. It's a big issue with Tesla right now. There's been a lot of stuff in the news lately. When they take these modules out of cars, it has, especially the certain ones associated with the display and the navs and stuff, it's got tons of personal data there. So they bring it into the dealer, they exchange that part out, but they're not erasing that data. And then those modules are going out for scrap or sale. And I guess a whole truckload of them ended up in Europe, and they solicit these modules and there's customer data on them. So there's a whole question of, okay, well, how do you make sure your data is erased from your car before you turn it back in? Think about it. If you rented a car and you connected your phone, there may be some data there. Usually it doesn't pull much, but maybe there's some there, or at least the navigation history in the car. Maybe you've got home on there. Maybe you've got work on there, and all your recent trips could be in there unless you clear them. So data's a big thing. Let's see here. Paul had mentioned Subaru uses cameras to also watch the driver to avoid driver's eyes closing. Yeah, and we'll talk more about that when we get into the drowsy driver stuff. Some of them are using cameras, some of them are using steering algorithms, how much your steering input changes. Are all the current systems active and the older systems passive? I'm going to take a leap and say, yeah, you're going to probably see the majority of the systems nowadays, let's say within the last 2 or 3 years, being active. Everything before that, I would say it depends. In many cases, you'll find the early systems from the Europeans being passive because it was new, and then they evolved active before a lot of other people came out with it at all. But a lot of car companies, by the time they came out with it, it was more, it had more miles under its belt, and they may have come out active from day one just because they came to the party later. And you do see that, you'll see the European stuff come out with a lot of these systems very early on, be out there for quite a while. Then you'll see it come into the Asian products, and then you'll see it come into the American products. And oftentimes the American products will get, a more, let's say, advanced system as their entry system because everybody else has already proven it out. Not stupid on their part, I guess. Kaylin, drowsy driver override is used in the trucking industry. You see it in a lot of cars now too. A lot of cars now. Early on, it was a camera, and they'd bring up, you need a cup of coffee kind of thing, or pull over and relax. But yeah, the capacity to then get into the steering, get into the throttle, it's just those next steps. We're not as far away from semi-autonomous and autonomous as people think. John, I investigated a Dodge or Chrysler minivan for a rental agency insurance company in a collision that monitored ABS, the throttle, and the airbags. Yeah. Airbag stuff is really common because when you think about it, in most cases, if you've had a vehicle that's deployed the airbags, oftentimes you've got to go back in and clear the faults out of that module for the system to refunction, even if you've replaced the bags and stuff, because it would hold that. Some of the early modules, it was one crash and it was done. Some of the later modules, it may be 2 or 3 clashes before they're done, or until they just won't reset. So that's a hardware thing that's evolved over time. Let's see here. Ed Snyder, we want pedestrians to survive so that after they collect insurance money, can now buy a new car and not be a pedestrian. Yeah, there you go. Ruben got the target in the chat. Let's see here. Rick Marshall, I know GM's been recording info from 90 to 2008, been to court twice for GM. And Jesse, always reset user data after renting a car through the radio display. Yeah. And a lot of that depends on the car. If it's in the radio or if it's in the nav screen, it's all over the place on getting into those things. Cool. Great conversation. So let's hit the next one. Now, hill descent control. Now, hill descent control is actually another one of these older systems. We were seeing these in the early 2000s, and it really came out with the SUVs because the idea was you had that East Coast driver who lived up in the hills a little bit, and the ice and the slush and the snow and the mud, and they had a steep driveway, and they couldn't figure out how to control their vehicles very effectively. They were typically all-wheel drive, and that's where a lot of the hill descent control came from. And there's probably a few different names, but the one that you see stick out the most is hill descent control. Again, SUVs a lot. You're seeing it on some of the all-wheel drive crossovers, trucks, again, four-wheel drive a lot of the time, but you're seeing these different things. Ed called it a duck button because of the way it looks. It will look like a duck. So again, this is a system that was meant for a very specific purpose, and it's actually a really rudimentary system. It doesn't have a lot of bells and whistles to it. It's pretty straightforward. So let's see how it works.
Your vehicle may have a feature that helps maintain a specific speed while descending steep grades. Let me tell you about it. Hill descent control allows you to set a speed that your vehicle will not exceed while traveling down a lengthy hill. When activated, the feature utilizes the vehicle's brake control system to help regulate its descent, allowing you to concentrate on steering. To use it, just press the hill descent control button here. You'll see a light in the instrument cluster, and a chime will sound to let you know the feature is activated. Now, using the accelerator pedal or brake pedal, bring the vehicle to your desired speed. The chosen speed is maintained once you remove your foot from the pedal. Keep in mind, maintained set speeds can only be set between 2 and 20 miles per hour. Although the system remains enabled between 20 and 40 miles per hour to assist the vehicle in its descent, it cannot, however, maintain a set speed higher than 20 miles per hour. You can adjust the speed at any time using the accelerator or brake pedal. It's that simple. It's important to remember that hill descent control requires a cooling down interval after a period of time. If the system is requiring a cool down interval, you'll get a warning in the message center and hear an audible tone before it disengages. At this time, you'll be required to manually engage the brakes to maintain a comfortable descent speed. To deactivate it, simply press the hill descent control button again, or it will automatically turn off when you reach a speed above 40 miles per hour, or switch the ignition off. Any questions? Go to owner.ford.com.
So hill descent control was really a way for the vehicle to take control on brakes and throttle. The driver is still driving the vehicle. And again, it's really meant for that steep driveway, that really slow speed. I guess you could, if you were out there rock crawling somewhere, it's probably not the right thing for you. But if you're just driving in a strange condition in Tahoe, hey, this would probably be an effective system. But notice again, very low speeds. The idea is it wanted to control the brakes and the throttle so that you weren't having to slam on the brakes and slide as much. It just kind of reduced everything down. So we're going to improve safety because we're not going to go as fast in a bad situation. And it's going to use some really basic sensors. Notice it doesn't say anything about cameras. No radar sensors. So, I wonder what it's using. It is an active system, so it's going to control throttle, transmission, and brakes. I haven't heard of a system yet controlling the steering, but hey, semi-autonomous, then we're there. But that wasn't really the purpose for the hill descent control. It was just to keep the vehicle slower. And also notice that they're talking 25 miles an hour or less. So this isn't coming down Grapevine. All right, this is meant for that steep driveway, marginal conditions, and just let the vehicle control itself going down the hill. Transmission range, brakes, throttle, it can control all those things. You just point, okay? You just point. Now, the customer themselves, what are they going to see? Well, they've selected it. They physically push the button to turn it on. They're going to get an instrument cluster indication for it. You're not going to get too many other feedbacks because there's really nothing else for it to tell you. It doesn't need to shake the steering wheel telling you it's in that mode. But let's think of some things here. If I'm in this mode and the wheels break traction, because we know physics, comes into play sometimes. If it started to slide, obviously it's probably going to try to throttle back even more. Would the system go into ABS? Maybe. It really depends on how the system's designed. I haven't read anywhere where they said, yes, it would go into an ABS control, because I don't think that they look at it as the situation where you would be in that type of an environment, it's saying, hey, you're going down this road and you're just not going to put your foot on the brake all the way down. But again, it's software. At what point does the system say, ooh, I need to go into regulation? And it just does it because of a regulation recognition, not as much a hill descent control recognition. And that's where some of these systems can get a little fuzzy. Just because I'm in hill descent control mode doesn't mean that ABS isn't still looking at all the wheel speed sensors. It doesn't mean that that system couldn't recognize a traction loss and go into an ABS regulation. Doesn't mean that it would, but it doesn't necessarily mean that it wouldn't either. It just depends on how they wrote the software and did they keep that in mind. What if the grade that you're going down dramatically increases or decreases? Is it going to slow down even more? Is the car going to get a little scary as the grade got steeper, but it still wants to go 20 miles an hour down the hill? What if it started to go up the hill a little bit? Yeah, because it's meant to help slow the vehicle and control the vehicle on a downhill. What if it went down the hill and started going back up again? It's not really meant as a cruise control in the sense where it's going to start climbing the hill the rest of the way. It's probably going to get to the bottom of that hill and maybe lug a little bit, and then you got to step on the gas pedal. What if the driver steps on the gas or the brakes? Well, if they step on the brakes or the gas, it tends to take that system and put it into a standby. It doesn't necessarily turn it off. It puts it into a standby, and then when you take your foot off the gas or the brake, it probably goes back into play. Once you go fast enough, and that speed depends on the manufacturer, once you get fast enough, then the system disables and you'd have to re-enable it. It's not an automatic thing to where every time you get in the car, it's going to be on. You're going to make an active function to turn it on each time you want to use it. What if you change tire size? How would that react on this system? Because we're not using cameras, we're not using radar, so what are we using? Wheel speed sensors. So if we're using our wheel speed sensors and our transmission speed sensors and our vehicle speed and all that kind of stuff, if I had tire changes, that's going to affect my vehicle speed. So maybe this system might go downhill a little bit faster, or maybe it goes downhill a little bit slower, depending on what I've done with those tires. The system thinks it's doing 25 based on factory spec information. But if I start changing things, that may change that. And what other systems could impact this? If I was having a problem with my drive-by-wire, if I was having problems with my transmission, if I was having problems with my brakes, I could have issues with hill descent. But if I had a problem with hill descent but didn't have problems with any of those others, it's probably not them. It's probably just related to the controls with hill descent. So components, you got a module or whatever module is incorporating that function, whether it's a separate or incorporated, that's coming into play. Engine management's going to be in play. Brakes are going to be in play. Transmission control is going to be in play. Wheel speed sensors are going to be in play. Control switches, you're going to have some sort of a visual indication, whether it's just the illumination of the switch, but there's usually something on the instrument cluster as well that's going to illuminate to say, hey, you're in hill descent control mode. Diagnosis, hey, this is probably the most mechanical diagnosis of all. We're looking at brake stuff, wheel speed sensors. But again, if I've got a wheel speed sensor problem, like the one in the picture, I've probably got fault codes. I'm not worried about my hill descent control problem. I've got fault codes for my brake stuff going on. So I'm going to see that much sooner. If I had problems with the transmission, the engine management, things like that. But we're back to those same fundamental things. You know, I would diagnose this like any other car. Duplicate the complaint, check for faults, check my bulletins, start doing the visual inspections, check my power, my grounds, my signals, all of those fundamental things. No different. I just don't have to worry about cameras and radar sensors and stuff. So, you know, it's a new technology or new-ish technology that, you know, even the old guys that just want to hit it with a hammer can still work on. Calibration. So I don't have cameras. I don't have radar. What would I need to calibrate? Steering angle sensor. Because I've still probably got an ABS at least, or most likely a stability control system. And that stability control system is going to want that steering angle sensor calibrated. So even with something as a basic system as a hill descent control, I've still got calibration that I've got to deal with. So this next video is just a very brief, quick look at steering angle sensor calibration. So here's something. We haven't really mentioned it. We've just today I started mentioning steering angle sensor calibration. Would I do the steering angle sensor calibration before or after I would calibrate my ADAS cameras and sensors? My personal thing, I would say before. I read John Taylor's lips on the window there. Before, because this is something you're doing at the end of your alignment anyways. I'm probably coming off the alignment machine, going on my flat bay to do my other calibrations. So this is something that I would have done before that. Probably wouldn't be an issue if I did it after, but why? I've got it on the lift. I've got to turn the wheels back and forth. I've got it plugged in if I'm using the Hunter stuff. I'm getting it done with before I go into the other stuff. So let's take a look and see what kind of questions we've got in here on this one. John Taylor, I've seen something that utilizes the transmission. Yeah, and again, it's using the transmission, the brakes, and the throttle as need be. You know, the throttle control is actually going to provide some engine braking where it can. The ability to downshift or upshift the transmission. It's going to try to do those things before it does the brakes, because let's be realistic. If the system's holding the brakes all the way down, the brakes are going to get hot and the system's going to have to back off. So the more we can do with engine braking and transmission mechanical braking, the better, and then the brakes supplement as it needs to. Paul mentioned, I assume you can still use the brakes while the system is active. You can, and like I mentioned, when you step on the brake or the gas, it kind of puts the system into a standby mode to where you're not really under hill descent anymore. You're now controlling the brakes. And he asked, what's the lag time of it responding to change of hill descent? You know, I haven't heard the couple of systems that I've driven. It was, you know, a very short distance, like on a ramp from a second story parking. It seems very reactive. You know, it wasn't like I was going down at a slope and then all of a sudden there was a bigger slope below it. So I can't really answer, you know, how big or how long it takes to react. Think of it as a little bit of like a cruise control. It holds fairly well where it can. But if physics come into play, if it starts getting really, really steep, it can only hold so much. You know, it can only let the gas off so much. It can only keep it in low gear. It can only step on the brakes so much. And at some point, it could start to diminish, and then the car is going to speed up some. Steve K, he's got a 2014 GMC, has hill descent, works well, can use the brakes as normal. System kicks in and out pending his intervention. Yeah, and that's what it's meant to do. And as long as you haven't exceeded the speed or haven't turned the button off, it's going to stay in that mode. It kind of goes out, it goes into a standby as you've assumed control. As soon as you relinquish control, then it takes back over again. Paul had mentioned, I bet if a speed sensor is bad, the computer will disable everything. And I think, you know, on early systems, stuff like that, I would say is probably true. Because the systems, when we think about how a lot of these systems have evolved, when one thing was bad, it stopped everything. And as they've evolved over time, what we've seen is they've used more and more logic. Take engine management, for example. A lot of cars in the old days, if you didn't have a crank sensor, the engine wasn't going to run. If the crank sensor died while the engine was running, it wasn't going to run. A couple years later, it said, well, wait a minute, I'm looking at a cam sensor. If the cam sensor's still turning, the engine's still turning, I can set my fault code, I can set my check engine light that I don't have a crank sensor, but I can still function enough because I see a rotation with the cam sensor. So logic has come in more and more with the vehicles, so it can lose something and still function at a very high level. CAN communications were like that. You lost one of the things in CAN, you lost everything. And now it takes a lot to kill CAN enough for things not to work. So they've gotten a lot smarter, a lot more stable. Mike Sherburne mentioned, may also reduce engine braking also to keep the wheels from locking. Yes, sometimes you will get cars, and they'll do this with cruise control as well. Sometimes they'll give it a little bit of throttle to give it engine braking, or give it a little more throttle to reduce the engine braking. It really depends on what it needs to do. Some newer vehicles don't have steering wheel calibration requirements anymore. Yeah, and that's where, you know, they've effectively made the system smart enough through a combination of sensors, not just a steering angle sensor, but maybe a rack position sensor and things like that, to where they're using logic. Hey, if this is straight ahead and zero over here, this is probably that way too. And that's just, again, it's using more advanced technologies, more logic, to say, I don't need just the one thing, I can use multiple things. Ed Snyder, some systems may use the same buttons to increase and decrease cruise control speeds to adjust hill descent speeds while in use. Check the owner's manual. So yeah, I've also heard, kind of like what they mentioned in the video, is, you know, you kind of accelerate up to a point, and when you hit it, that's what it's going to hold it at. But again, the whole thing wants to stay below that 20-something miles an hour. Steve K, hill descent likes to work, especially during long grades. Yeah, if you're going slow enough, you know, and it's nice just pointing the wheel, and you're not having to get on and off the brakes and on and off the throttle and everything. So it makes it an easier drive. And that's one of the things, as you spend some time driving these vehicles with these systems, it's a different driving experience. It's a lot more relaxed. But at the same token, I know for myself, when I've driven cars a long distance with these systems, I can see where my attention isn't as much. I'm not as tired as I would normally be, because I hadn't been as focused as I would normally be. So when you have more nanny controls in the systems, yeah, you're more relaxed, but that's also the downside, is you're more relaxed, you're not as attuned, not as attentive, and you start to rely on the systems to do their job. And so I think it's a little bit of a scary time having it that way, to where, you know, we're relaxed enough that we're trusting it, but if it may not be as perfective as we would want it to be, and it could put us in a bad situation. So we're kind of in the middle with them now. So that's all I've got for you guys. If we've got any more things, go ahead and throw them in the chat. The next session is going to be the Friday after the 4th of July. I forget what that date is. So it's like the 10th or something like that, I think.
July 10th.
Cool. And we're going to talk about front vehicle departure warning. And this is one of those things a lot of people didn't even have an idea that it existed. We're going to get into that adaptive lighting that Mark was talking about, to where, you know, headlights aren't what they used to be, guys. There is a lot of stuff going on with headlights. And then also emergency braking, which starts to tie in with, you know, some of our front collision warning, but overlaps a little bit more with pedestrian stuff as well. So if anybody's got any questions, throw them in there. Otherwise, that's all I've got for you. You know, enjoy the holiday, and I'll see you in a couple of weeks.
And just
Thanks,
let
Kurt.
you all know, before you all take off, I'm in the process of confirming to your deans and your payment folks about your payment, your compensation. So I'll copy all of the Bay Area Community College auto faculty on those emails that I sent out, so that everybody knows how this is going to occur. And I'm giving everybody a heads up now, so that they can have all of that in preparation for payment in August. So I am using, just so you know, Zoom has a number of reporting features, including all of the time and attendance records for these calls. So that is the basis for the calculation of your hours for both training and for the payment and compensation procedures. Some of the deans have already asked for those records, so just to let you know, that's the basis for how those things are going to be calculated. If you have any questions, once I sent those emails out, which will probably be on Monday, you can get back to me, but hopefully this will go smoothly. I hope. But it's funded by the RJV for automotive. So it's going to be a transfer from City College to your respective colleges. And that'll happen in, well, I don't know when the payment will go through, but all of the procedures will be in place in August. I hope. Anyway, have a wonderful weekend. If there are no further questions.
I haven't seen any come up.
I don't see any either. We'll see you all on the 10th. Have a great holiday next week and stay safe.
You too. Be safe.
Thanks, everybody.
Thank you.
See you later.
Bye.
Thanks.
Good job, Kurt, as always.
Thank you. Yeah, just make sure you log off, guys. We got nothing else going. Pam and I just stay on, talk for a couple of minutes. You want to go ahead and stop the recording too.
Yeah. Now, you and I must have done this